So without further ado, I want to introduce one of those cloud people that's managing them and making everything copacetic from Amazon Web Services, my guy, Mr. DeJuan Lightfoot. Y'all give some noise for him.
Thanks, man. Applications have evolved. And as developers develop today's applications, you care about speed, agility, and scalability. The underlying network is not something you care about. It should just work. And as a network engineer, from what I've seen, is that if the network gets in the developer's way, they learn to abstract it and build on top of it. Think of virtualization, containers, and Kubernetes. And honestly, I agree. The network should not get in your way. You should just be enabled to develop and not have to worry about the network. And this is where application networking comes in. My name is DeJuan Lightfoot. I am a developer advocate at AWS, and today we'll be discussing demystifying application networking. Now, I think it's important that we pose today's conversation around a question. How do we make it simple for developers to connect, secure, and monitor your services without sacrificing the controls admins need to audit and secure the environment? Let's talk about today's agenda. We're going to start off with discussing the need for service-to-service communication. Then we'll move on to talk about the challenges of modern applications. And then we'll answer the question of what is application networking? And finally, we'll talk about how we simplify application networking on AWS. Now, how many of you have heard of the OSI or TCP/IP model? How many of you are developers? I love this crowd. How many of you love talking about the TCP/IP model? That's what I thought. Well, we're going to do a quick overview of the TCP/IP model because I think it's important before we even talk about service-to-service connectivity that we discuss device-to-device connectivity. Now, when we're looking at the TCP/IP model, it's broken up into a few different layers. At the application layer, this is where you have your web servers as well as your email clients. At the transport layer, you have TCP, UDP, along with your ports for your applications. At the internet layer, you have your IP addresses for your source and destination. And finally, at the network access layer, this is where the communication is packaged into a frame and sent across the network to the connecting device. Now, on the left, we have our web client, and on the right, we have our web server. The web client does a HTTP GET request, sends that to the transport layer, where the transport layer takes that UDP or TCP request, and then from there, it assigns a port, it already knows the destination port, and moves that segment to the internet layer. At this point, you have your IP address source and destination into your IP packet, and then it moves into a frame and moves across to the destination server. And if we look at this in our model, we can see how this works across the network. Now, if we watch this, this looks pretty seamless, it looks effortless, but from an admin, a network engineer, which is my background, it's not always this simple because this communication flow isn't always this same IP address. It could be discontiguous networks. It could be overlapping IP addresses. In order to make this communication happen, there's some challenges that you could have to alleviate. So this is just service-to-service connectivity, device-to-device connectivity, just kind of starting this conversation when we're talking about application networking. The second piece we need to talk about is going to be that service discovery. And in order to talk about service discovery for our applications, I think it's important to understand where we were and where we are. In this example, we have a monolithic application. What is that? Monolithic application is basically an application that's a collection of services that sits on an instance that's on the same runtime, and in order for you to make a change to that particular service on that application, you got to redeploy the whole entire application. Now, if you're wanting to have high availability, you put a load balancer in front of that, and you have different versions or different numbers of those instances of that monolithic application. In order to communicate with this application, you're going to need some type of service discovery. Most of us know about DNS. We do a DNS query for example.com to be able to communicate with the load balancer. And at this point, the client can communicate with the application via the load balancer, and the load balancer will distribute traffic for the monolithic application, maybe in round robin or something like that. So we talked about service, device to device, service to service connectivity, along with service discovery. But there's a couple challenges in this because there's some things we need to talk about. Now, on AWS, we solved the problem of service discovery with Route 53. Most of you may be familiar with Kubernetes. Kubernetes uses core DNS. And I mention Kubernetes because the monolithic application solves some specific problems, but organizations are evolving from the traditional monolithic application to more of a distributed microservices architecture, where now you take your monolithic application and you break it down into hundreds, maybe thousands of microservices, and each one of those microservices may be in its own VPC, in its own subnet, and this comes with some new challenges for admins in the industry. Developers are having a field day because now they can be on different teams and focus on their one particular microservice and package this all up in a Kubernetes environment, and they're having fun. But for the admin, networks are becoming borderless. And we'll talk about that here in a moment. So I mentioned the admin challenges. As you developers and your teams grow, you scale, you're taking your services, you're deploying them in different VPCs. This is changing the network boundary as well as the security boundaries for your applications. So as a monolithic application, this was pretty simple to kind of manage compared to the microservices. Because when we think about microservices, it changes the boundaries. Because now we have to worry about NATs. We have multiple VPCs here. Each one of these VPCs had their own CIDR blocks. Now to a developer, this may mean that every VPC you do a 10/16. That sounds great, until you have to connect them all and realize there's IP address overlaps. That introduces challenges. Maybe you have sidecars and you're introducing proxies. How do you connect those to lambda functions? How does that, if you have different compute types? Which here, we have several different compute types. How do we make all of these communicate in our applications? How do we remove those challenges that we face? How can we centralize the management of not only the network connectivity, but the security and the monitoring of these services between each other? Now, before we move on to really dive into the application part, I want to talk about the service-to-service connectivity on AWS and how does this happen between VPCs. Here, we have VPC1 and VPC2. One way that we connect these VPCs is through an internet gateway. What is that? Well, basically, you open up a hole in your VPC, and you establish communication between these two VPCs via IPv4 or IPv6 public addresses. Now, again, I said open up a hole. This is a pretty broad hole because you're opening up this to the public internet, although you're traversing over the AWS backbone. For some customers, this doesn't work because it may not be as secure or efficient as they desire. So if you want something a little more granular, then you use an AWS Transit Gateway, which is basically a hub and spoke technology, with your hub being a transit gateway and your spokes being your VPCs. So if your VPCs need to communicate, you do this via the transit gateway. Now this provides a little more segmentation because you can use those private addresses as you traverse through the transit gateway. Next option is going to be VPC peering. This is going to be your bi-directional one-to-one communication between your VPCs. I mentioned one-to-one because the transit gateway allows you to connect multiple VPCs. The VPC peering is basically a peer-to-peer connection between two VPCs. And so this is a little more security as far as what you're allowing access, but it also can be more challenging if you're leveraging VPC pairing for, I would say 50 or 100 VPCs. Now, even more granular, if you want to provide or produce a service from your VPC and allow your customers or other VPCs to consume that service, we have AWS Private Link, which basically you take your service, you build it, put it behind a load balancer, and you allow your customers or clients to consume that service. This is even more granular. So this is kind of solving the problem of, well, not even problem, this is solving the networking infrastructure connectivity, the service-to-service connectivity at the infrastructure layer for the admin. But as a developer, you still have a challenge because as you're developing your applications, you're kind of at the mercy of the admin to implement this infrastructure, to update this infrastructure, to solve the challenges of the next. So this is keeping you from delivering at the speed that you desire. And those are some of the challenges that I just discussed. Now, another challenge alongside the network connectivity, if we move up the stack to the application layer, it's going to be that service discovery. I talked about the layer 3 connectivity. That's all we just talked about. There's challenges there. How do you manage traffic once you get past that layer 3 connectivity? How do you do that? If you have different services, you want to route them via load balancer to different paths or based on paths or headers, how do you do that? How do you manage your authentication and your authorization? How do you ensure you have full visibility, not just from your network layer, but your entire stack? How do you get that? This is where application networking comes in. Application networking on AWS is a collection of services that provides developers tools in order for you to centrally, securely monitor and connect your services at the application layer. There's 2 building blocks here, and I've been talking about them throughout this talk. That's going to be service discovery and service connectivity. On AWS, we have a collection of tools, a collection of services to help solve this challenge. Elastic load balancers, CloudFront for your content delivery networks, AppMesh for your service mesh, CloudMap, which is another DNS type service for your APIs, Private Link, which for your private connectivity. And for those of you that want to know more about this, I will have a slide at the end where you can scan the QR code and read up more on it. And also I discussed Route 53 as well as API Gateway, which I'll cover here in a second. But the main point of this talk we'll get to, which is going to be Amazon VPC Lattice, which I think is an amazing service that we announced at reInvent 2022. Now, if you remember this slide, I talked about the network connectivity and how the admin manages this, but it can slow the developer down as they develop their applications. Now, at the application level, once the network infrastructure is implemented, you have all your routing, you're good at layer 3. Now we can talk about the service discovery. I mentioned one option is going to be Amazon 53, Route 53 for DNS, as well as AWS Cloud Map. Now for your application layer routing and our auth, we have API Gateway and our ALBs. This still is a collection of services and tools that may be managed by a developer, may be managed by an admin. There's some challenges here. And for those of you that are in Kubernetes environments, you may be thinking, well, why don't I just deliver a service mesh for my Kubernetes workloads? And if you don't know what a service mesh is, a service mesh basically takes and has a centralized control plane and a distributed data plane that has sidecars. Sidecars being application layer proxies that are deployed beside your containers that live in your pods or your Kubernetes clusters. So this allows you to separate your business logic from the network portion. So you developer can just focus on developing your code, and then at the service mesh, you can control the networking and proxies for your infrastructure. So once the service mesh is deployed, Kubernetes is working, it's functioning. But how do you deploy a sidecar beside a Lambda function? Let's say you got an EC2 instance. Maybe you have blue-green deployments. That's going to be outside of your, how do you get that connectivity outside of your service mesh? And this is where VPC Lattice comes in. VPC Lattice allows you to take that service-to-service connectivity that I mentioned that the admin would implement and do this right in one service, one centralized control plane. This is a fully managed service that provides you that service-to-service connectivity along with your application layer routing of your paths as well as your headers across multiple VPCs and accounts. It does the service discovery. I mentioned the load balancing, your authorization and authentication, your observability, and it does this across different compute types. So if you have instances, you have Kubernetes, you have Lambda functions, you're able to manage this all inside of VPC Lattice. So how does this look? And here we have a client. The client is able to communicate via DNS to all of the services that are associated with VPC Lattice. Each of these services are different compute types. Notice Service 3 is in Kubernetes, EKS. Notice Service 4 is in the autoscaling group of EC2 instances. And Service 5 is going to be a Lambda function, and Service 2 may just be some instances behind a load balancer. The client is able to establish this communication via the DNS. So what does this look like? There's 4 different components of VPC Lattice. We have the service, we have the service network, we have the auth policies, and we have the service directory. If we break down each one of these services, a service is basically your application of running instances, containers, Kubernetes, containers, or Lambda functions. What it does is you have your service, you have a listener that service listens on. In this instance, it's 443. You create a rule, which is going to be a path or headers. And then you have your target groups. And behind your target groups, this is where your instances, your Kubernetes containers, as well as your Lambda functions live. And so when someone wants to connect to your service, you can define your blue-green deployments. Let's say 70% of your workload should go to your containers and 30% of your workloads goes to a Lambda function. You can define all this in your service of VPC Lattice. The next component of VPC Lattice is going to be a service network. Here is where the admin can define the logical and security boundary for your service-to-service connectivity along with your service discovery for your environment. After that, if you all are familiar with IAM resource policies, you can use auth policies to define that service-to-service connectivity of what can communicate to your service as well as your network. And I'll show you an example here. When I mentioned you can kind of separate those roles. The admin is responsible for the network, so they create an auth policy. The developer is responsible for the service, so they create an auth policy stating what can communicate to the service. So this allows you to separate those roles, and I'll show you how we can do this more efficiently here in a moment. And the last piece is going to be the service directory. So you've created your services, you associated them with your service network. Now you can share out that service across accounts. And these accounts, via the resource access manager, you are able to verify and view and utilize and consume these services via the resource access manager, or RAM, on AWS. Now, I mentioned who does what. The challenge in the beginning was that the admin wants to have control of the network and the environment. They want to secure that environment while enabling developers to develop their applications. Developers just want the network to work without having to worry about the TCP/IP model. So with VPC Lattice, what we can do is have the admin worry about creating the service network, defining the access and monitoring for the service network, and then associating VPCs and services to the service network and then sharing those out to other accounts. And so once that service network is shared out to other accounts, at this point, the networking is defined, the security is defined. The service owner can now worry about developing their code, creating their service, and then creating a service in VPC Lattice, defining the routing to that service, the authorization to that service, and then associating the service to the network that has been shared to the developer. This removes the need to depend on the admin to manage the network connectivity. And another thing that I did not mention is that when you're developing your when you're creating your VPCs, when you're developing your applications, there's NAT, right? NAT is a major thing we worry about in our networks. Solving that IP address overlap, VPC Lattice natively handles that. So if you have a 10/16 in one VPC, 10/16 in another VPC, connecting those or associating those VPCs with VPC Lattice, it automatically handles the NAT with no need for the admin or developer to do anything else like add NAT gateways. So this solves the problem. The admin is able to control, maintain the network with all the security controls that they need, enabling the developer to develop their applications, and the developer is able to develop their applications without having to worry about the network because it just works. If you all would like to know more about application networking, here's a QR code. And also, there's a workshop that is readily available if you want to try VPC Lattice out for yourself. I'll give you all a moment to scan both of those. Awesome. And this completes my presentation. My name is Lightfoot. Like I mentioned, I'm a developer advocate at AWS focused on cloud networking. This talk was amazing. It's been great to be at Render 23, and I hope to see you all at RenderATL 2024. Thank you. Peace.
Dewan, thank you.